All right, hello everyone. So, for this week's Monday assignment, we're going to continue on with our investigation of why transferring energy into or out of a substance changes the molecule's freedom of movement. So, remember this idea of freedom of movement is referring to how much molecules can move in a space. So, how much are they able to move around? So, as we see these different phases, we want to notice that their freedom of movement looks a little bit different depending on the amount of energy in each of the phases. So, last class, we were talking about kinetic energy and how it's related to freedom of movement. So, kinetic energy, this is the energy that an object has because it's moving. So, this refers to just the energy something has because it's moving around. And then freedom of movement, this is the way molecules in a substance move around relative to each other. And from last class, we know that these two, kinetic energy and freedom of movement, are connected. So, again, kinetic energy refers to how fast these molecules are moving. So, how fast are they moving in each of these phases? How much are they able to move around? And this idea of kinetic energy is what we can see at the molecular scale. So, this refers to what we can see on the molecular scale. And as we've seen kinetic energy change based on transferring energy in or out, we also notice something else that has been changing along with it. So, circling back, so remember that we want to understand that transferring energy into a substance increases the molecule's freedom of movement. So when we transfer this energy in to the substance in the starting phase, it will increase the ability of the molecules to move around. So those molecules will start to move around a lot more when we transfer energy into a substance. Whereas transferring energy out, so if we take energy out of this substance, the molecules are going to start moving around a lot less, like you're kind of seeing on this picture right here. Oops. So when we transfer energy in or out, like I was saying, something else was going up or down depending on what we were doing. So we want to remember that temperature was also affected as we transferred energy into or out of a substance. So, this idea that temperature increases as energy increases can also be reflected in this graph. As we see here, we have low energy in our solid phase, as well as a lower temperature down here, right? Because it's going to be below that melting point. So, it's got to be below 0 degrees Celsius. Then we're going to come up to this higher energy phase where that's where we see our gas phase. And gases, we remember that they exist at higher temperatures. So as you go through the rest of the Nearpod, I want you guys to use the information that we've gathered to analyze the models and answer the questions thoroughly in complete sentences. Use this evidence that we've gathered throughout our last few classes to help us figure out this relationship between temperature and energy, and also whether our claims are supported or refuted. So take a moment and complete the rest of the Nearpod, and you can always refer back to this video if you need additional reference for your evidence. I also want to point out that at the beginning of the Nearpod, there is also a lovely key vocabulary table. So you can click there and it will give you the Unit 3 phase change vocabulary with some images and definitions to help you out. So please reach out with any questions, and I'll see everyone tomorrow and Wednesday.